Hey guys, how's it going? I just wanted to make this video to help you guys out with this problem for those of you who either had to leave the SI session today a little early or were confused by what I said or what her solutions were, or if you couldn't make it to the SI session at all. I really want to make sure that you guys have this problem down really pat. I know it can be a little confusing, but the hardest part is going to be figuring out what it is that you have and figuring out what it is that you're being asked. And that's the most difficult part of a word problem. So I want to go through that with you and make sure that you understand what it is that you're trying to do here, and we'll go from there, okay? So in this problem, they're saying that the following equation is used to calculate the average firing rate of a neuron. A function of the concentration of X neurotransmitters in the synapse. So what are they saying? They're saying that this is a function, okay, and that X here is what? The X is going to be our concentration of neurotransmitters. Okay? Now, the function, okay, the function is the firing rate. Okay? The function, the firing rate, that's telling us what the firing rate is. So depending on what the concentration of the neurotransmitter is, we have a certain firing rate. I know this seems a little simplistic, but this is the hardest thing to extrapolate from this type of problem. So y is equal to the firing rate. I would get this down first before I do anything else. Okay, and again, I want to do most of this without math, so you understand what's going on. So we know that much. And they say find the horizontal asymptote. Okay, let's just deal with that part first, okay? Find the horizontal asymptote right here, okay? So basically they're telling me there is a horizontal asymptote. So what does a horizontal asymptote look like? Well, we have some function here, and we know that there's some kind of horizontal asymptote. This is only going to be in the first quadrant because I'm not going to have any negative concentrations here. And so since X is going to be my concentration and Y, my function, is going to be my firing rate, then you can kind of see from this that the concentration increasing is going to do something to the firing rate. As the concentration increases, it'll do something to the firing rate. I bet you could pretty much take a good guess as to the fact that it's going to increase it. If you have zero concentration, then it's just going to have zero firing rate. That makes sense. So having said that, you could think that the point 0, 0 is on your graph, okay? 0, 0. Now they're telling me that I have some kind of horizontal asymptote. I don't care where it is. I'm not doing any math yet, but I have some kind of horizontal asymptote, okay? I don't know where it is. I don't know anything about it, but I know that I have this graph of the concentration of a neurotransmitter, and as that increases, then the firing rate increases. So here's the thing. If I was up here somewhere, then I couldn't get past this line. If I'm down here somewhere, I can't get past this line. So since we are down here, we know that this is a point, we know that 0, 0 is a point, I can just figure that out because it's the only thing that makes sense. Then I know that my function has to do something like this. I know that my x values are going to increase in some way. I don't care how, but they're going to increase in some way. And they're going to hit a cap, this ceiling here. They're going to hit this point where you can't do anything else. So I could draw a pretty rough estimate as to this. Okay, I know that it's going to grow exponentially, kind of, and it's going to bottom out. It's going to start sinking out here at the top, and it's going to hit a brick wall. It's going to hit that horizontal asymptote. Again, I haven't done any math. I haven't done anything at all yet. So, if they're telling us that we have this horizontal asymptote, okay, we have a horizontal asymptote, then how can I find that? How can I figure out what point my x values are going to hit and bottom out on if they increase and increase and increase? Well, as my x values go off to infinity, as they just increase and increase, as my x values go off to infinity, they're hitting this brick wall. So if I want to find out what that brick wall is, then let me figure out what the limit as x approaches infinity of my function is. Okay? So if you look at her solutions there, that's exactly what she does. She takes the limit as x approaches infinity of the function to figure out what point they're getting stuck at, what point they can't go on. Okay? And so if you do this, then you can divide by the highest power of everything. And so in the highest power here is just this e to the 3x. Okay, so just divide by that. And you're going to get that this just goes to 20, this just goes to 1, and this is going to go to 0. Okay, so you're going to get 20 over 1, so you're just going to get 20. So that's going to be your horizontal asymptote. That is the point at which your x values are getting stuck. That is the point in which no matter how much acetylcholine neurotransmitter concentration I have in my neuron, I will no longer be able to synapse. Your nerves have a certain threshold that they cannot go past, so no matter how much concentration you have, it can't work any harder. And that's what this function is explaining. This function is explaining the work that your neurons are putting into synapsing dependent on how much neurotransmitter you have. Okay? So now that we've done that, they're asking us, find the x values that are within 5% of its asymptotic value. Okay? So what is that saying? Within 0.5%. 0.5%. What is this saying? Within 0.5% of its asymptotic values. Okay? That means that we want it to be plus or minus within 0.5% of this line that we have up here. We want it to be within 5%, 0.5% of that line. Okay? So if this is minus 0.5% and this is plus 0.5%, well, then it would seem kind of silly to think about the plus 0.5% because if I can't cross the line, then I'm not going to go above it. So we can just scratch that out. That just seems silly. Which means that the part that I'm interested in is here. I'm interested in when my function is going to be between 20 and 0.5% below 20. So 0.5% below 20, 0.5% of 20 below 20. You can think about that in a couple different ways, but you could just think about the fact that, well, you have 20 times 100% minus 20 times 0.005. And that's percent again. 100% is 1. 0.5% is 0.05. And that's going to give you 20 times 0.995. You could have also just skipped straight to this. If you could just think about the fact that, okay, well, I have my ceiling and I want to be all the way to my ceiling, but I want to be just 0.5% below it, so I know that that's what I want. So now that we have this is our value that we want to be between, and we have this is our horizontal asymptote, which is how we got that. Okay, now I want to take my function and I want to find the x values. And again, we've barely done any math. We've taken one limit here. Okay, I want to find the x values that fall within this range. I'm interested in the x values that fall in the range between these 2 points, between 20 and 99.5% of 20. I'm interested in this area here. Okay, this is the only area that I'm interested in. So I'm interested in figuring out when the x values are going to be, you could say, greater than or equal to this point here, and that's it. Because if they're greater than this point, you know they're never going to be greater than this point. So if they're greater than this point, you know they're less than this point, then the x values that are greater than or equal to this point here are going to be all the values that fall within 0.5% of my asymptotic value. So how do I write that? I just want to say, well, I'm looking for all the values in my function that are greater than or equal to that value that I came up with, this guy right here. Okay, that's it. Problem's done. After this, it's just some silly math. And the math's easy. Okay, so I just want to take my function, my f of x, and I know that that's 20 e to the 3x over 2.1 plus e to the 3x, and I want to say that that's greater than or equal to this guy right here. Okay? Now, there's just one more trick I want you to see. If I want to solve for x, I only want one x in there. Okay? So let's take a little stroll on over here on the side, okay? If I had, let's just say that instead of e to the 3x, we have u. So we have u. Okay? We have 20u over 2.1 plus u. I want to get u by itself. And when I want to get something by itself, I want to be able to factor it out. But I can't factor out u from all of this because of this guy. He's ruining everything. So, just like when we multiply by the complex conjugate and many other things, we like to multiply by a complicated form of 1. Okay? So I can just multiply that one guy, that 2.1, this one right here, I can multiply him by u over u. I'm not breaking anything, I'm not cheating, it's just 1. Okay? I'm just multiplying by 1. And now I could say plus u. Okay? These two things are the same. I didn't do anything wrong, I didn't cheat. This is just u over u. I just multiplied by 1. But now, sorry, I forgot a u there on the top. U. Now I can take out a u from both the top and the bottom. Okay? So now I can say that this is equal to, I'm going to take out a u from the top and I'm going to be left with just 20. And then on the bottom here, I'm going to take out a u from the bottom. I'm going to be left with 2.1 1 over u plus 1. Which now, you know that 1 over u, how can I rewrite that? I can rewrite that as u to the minus 1. So that means I can write this, now that this cancels, it just goes away, it's 1 over 1. I can write this as 20 over 2.1 u to the minus 1 plus 1. That's it. Okay, but now remember the fact that we had that u is e to the 3x. U is equal to e to the 3x. Okay, if you need to use some kind of substitution like this to make more sense of things, that's fine. Okay, so now we have 20 on the top here. We have 2.1 u to the minus 1 plus 1 is greater than or equal to 20 times 0.995. And if you notice, you can just divide by 20 on both sides, and this whole thing gets a whole lot simpler. And that's it. After this, now we can just say that this is e to the 3x, and since that whole thing was to the negative 1, it's just 3x. We have e to the 3x to the negative 1 is equal to, those multiply, e to the negative 3x. So that's going to be the hardest part about setting up the problem. After this, you just have to solve for x, and that's really straightforward and simple, and you all are completely capable of doing that. So I have faith in you, but I wanted to make sure that you have this whole concept down, and I want you to really understand what you're doing. So good luck tomorrow, and I'll see you guys soon.